Hello, my name is Carlos Ramirez. Thank you for being here, and my work is called Chemoinformatic Analysis of Natural Products from Mexico. First, I would like to give you a little introduction. Chemical databases' main objective is to store, to process, to organize, and to disseminate small molecules and their properties. Natural products have great importance in the drug development. From 1981 to 2019, there have been approved around 1,800 drugs, from which around 3% are natural products and around 18% are natural products derivatives. Finally, DIFACQUIM is one of the first natural products databases developed in Mexico. It includes around 500 compounds isolated and characterized in Mexico at the School of Chemistry at the National Autonomous University of Mexico. The objective of this work was to update and characterize this Mexican natural product database using chemoinformatic tools. The methods include the update of DIFACQUIM. This was made by a bibliographic research of publications related to the isolation and characterization of natural products in Mexico. Different information was extracted from these publications. In the case of scaffold content analysis, it was made to identify the most frequent scaffolds in DIFACQUIM using Bemis and Murco definition. The third method was the characterization with physicochemical properties. To do this, 6 physicochemical properties were calculated: the partition coefficient, the molecular weight, hydrogen bond acceptors, hydrogen bond donors, rotatable bonds, and topological polar surface area. And a statistical comparison of these properties with 8 reference databases was made. The last method was a principal component analysis to generate a physicochemical properties-based visual representation of the chemical space. In this slide, I show you the results related to the update and the scaffold content analysis of DIFACQUIM. DIFACQUIM was updated to 605 different compounds, and it contains around 311 different scaffolds. The 10 most frequent scaffolds are shown in this histogram, and the most frequent scaffold is benzene. In fact, it is the most frequent scaffold of different natural products databases. The second one is flavone, and the third one is benzodiazole. Here I show you the box plots for the physicochemical properties of DIFACQUIM and different reference datasets. Based on the mean of the partition coefficient, DIFACQUIM has more lipophilic compounds than the approved drugs. We can see the values in orange in the table. And based on the standard deviation, DIFACQUIM is the second database with the largest distribution of molecular weight, total polar surface area, and the rotatable bonds. Because of time, I show you just the table related to the molecular weight, where you can see in orange once again the values associated to DIFACQUIM and approved drugs. DIFACQUIM has also the largest distribution of the HBA. Finally, I show you here the physicochemical properties-based chemical space visualization, where the first 2 principal components capture the 90% of the variance associated to the 6 physicochemical properties. The HBA and the TPSA are the descriptors with the largest contribution to the component number 1, while the coefficient of partition and the molecular weight are the descriptors with the largest contribution to the principal component number 2. From the chemical space visualization was determined that the chemical space of DIFACQUIM overlaps with the approved drugs and natural products different databases that we used as reference. Here I have my conclusions, where DIFACQUIM was updated.
Carlos, are you finished? We can't hear you. Okay, just a minute. I think Carlos reboot your computer.
Hello. Sorry, I got lost in my internet, so I don't know if I have time for a question, maybe.
Yes, you have a time, and let's from the first question from Vladimir Sulimov: how to obtain this database in electronic form?
I can send the link so you can download all the information of this database. We have only the first version. The second version, it is not possibly to download yet because it is part of my master project, but in a few months, I think you could be able to download all the information.
Thank you. Another question from Marcus Tullius Scotti: how data curation was carried out?
It was made with the MOE software. It is molecular operating environment, and it could help us to delete the salts and get the more stable structure of all the compounds.
Okay.